Hello, my name is Philip and this is the first tutorial from the series of tutorials focused on development of Algorand using Raspberry Pi. Firstly, let's talk a bit about motivation. In order to develop on Algorand, we need to set up a node. In this tutorial series, we will be using a Raspberry Pi for such a development. In addition, the node can also participate in the consensus mechanism, which is something what we cover in the part 2 of this tutorial series. Therefore, in case you have a Raspberry Pi installed, you can navigate directly to the tutorial part 2. Overall, the tutorial series aims to discover what are the node's capabilities and how to explore them. So, without further ado, let's start with the setup of the Raspberry Pi. What is a Raspberry Pi? A Raspberry Pi is a powerful embedded computer using ARM architecture of CPU and can have 1 to 8 GB of RAM. Our Pi has 1 GB of RAM. As a storage, it is used a micro SD card where we have 128 GB of SD storage. And in addition, it also offers various IOs such as HDMI, USBs, and audio jacks. It runs on Linux-based operating systems, and we will be using the official Raspberry Pi image. However, you can choose also Ubuntu or other distribution for your specific use case. And for the scope of the tutorial, we are using a Raspberry Pi Model 3B. So how do we set up the Pi? So firstly, we have to download the official Raspberry Pi tool, which will be used to install the operating system on the SD card. And later on, we will set up the remote connection between the Pi and my computer for better management. And finally, our network will look as follows, where both my computer and the Raspberry Pi are in the same local area network, and they both have connection to the internet. So, let's have some fun. In the first step of the setup, we navigate to the Raspberry Pi official homepage, to the software download section, and from here we download and install the Raspberry Pi imager for a corresponding operating system. I have already done it and it looks as follows. So looking at the Raspberry Pi imager, we see it offers the choice of the operating system, the choice of the SD card, and later on, of course, the option to start the writing on the SD card. So firstly, we navigate to the choice of the SD card. As you can see, we have 128 GB of SD card space. Choose that one. And then let's have a look on the choice of the operating systems. From here, we see that there is quite a variety of options. So we can choose different types of Raspberry Pi operating systems, which we will go through later. We can also choose some other game operating systems and so on for different purposes. This is not something interesting to us. And in case you want, you can also specify your own custom image, for example, of Ubuntu, which you have downloaded to your machines. In the first step, important for us is to format the SD card to the FAT32, since as long as the SD card has capacity larger than 32 GB, we have to do this step, since originally it's formatted to exFAT, which will not support the installation of the image otherwise. And we hit the write. Just to note, in case you start the formatting, you have to keep in mind that this operation is non-reversible, meaning that all the data on the SD card will be erased. After this operation is over, we start again with the selection of the SD card and the choice of the operating system. The Raspberry Pi can be installed in 3 different options. So the first option is using the light version, which is basically just a command line interface without any desktop environment. Second option is the full, meaning that we have the desktop interface and also other recommended applications. And final, let's say the standard one, we can call it, is the desktop variety. So we have also the graphical user interface, and we have some pre-install application, but it's not so bulky and does not contain so many information. So for us, this should be the sufficient option. And we hit the right button. Again, same as in the previous case, even now we already formatted. In case you don't have to format your SD card, just keep in mind that this step is non-reversible, and you will erase all the content of your SD card. So after we installed the Raspberry Pi operating system on our SD card, I plugged it into the Raspberry Pi. So here you can see the overall setup. So I have keyboard and mouse connected directly to the USBs on the Raspberry, as well as an HDMI cable connected to a monitor, and of course the power supply. So after you boot the Raspberry Pi for the first time, you will be prompted to insert the country where you are connecting from, and also you can choose the language of the system and the time zone. So this is of course your personal preference, and during the setup you will be also asked to connect to your Wi-Fi, or you can also connect directly through a wired connection if you have a cable, because the Raspberry Pi has a port for Ethernet as well. And then you will be prompted to install recommended updates. So I strongly encourage you to do so. And as introduced in the previous images, we want to set up now the remote connection. So this one we have done in 2 steps. So firstly, I have also installed a remote desktop connection, so I can show you how this looks like. So on the Windows, we are using directly the remote desktop connection instance. With here, we basically can provide the IP address of the Raspberry Pi and later on log in with the Raspberry Pi credentials. This is something what you have to know, which credentials to choose. And how did we achieve, or what was the necessary steps required on the Raspberry Pi side? So of course we, just in case, also run the update. I also in addition installed the Vim, and here is the important part where we are installing the remote desktop package to basically have the access over the remote desktop connection. And using the command IP address, I find the VLAN interface with the corresponding IP address. In case, for example, you are connecting over interface such as Ethernet interface, you will basically see the IP address under the interface name Ethernet 0, and then basically this one you can directly use to the remote desktop connections, as you could have seen in the previous setup. Great, but only this way we are basically able to connect over the remote desktop connection, which of course is not a recommended stuff, or some people prefer it, but for me I prefer to have a connection over SSH. And for that it's important that I firstly go to the SSH config, or which is under the path eth sshd config. And here in the first place I make the port open, which is done by uncommenting the port 22, which is originally commented, and I uncomment it, and then basically I close this, I close it, and that way I can connect from my local machine over SSH to the Raspberry Pi. And here on the local machine I also do some additional steps, because of course I could directly just do SSH Pi Raspberry Pi to SSH, it will work, but I want to start with a better way of doing it, which is by generating a private and public key pair locally, which is done using these steps. So I firstly do the SSH keygen, where I will be prompted to provide the path where I want to store the private and public key pair on my local machine. So here I choose this path. I can also choose the passphrase in case I want to make the private key encrypted, and basically with this passphrase it will be decrypted on the fly. And then I copy the public key to the Raspberry Pi using this format. So I specify the public key since I'm directly in the directory of the .ssh, and I want to copy it to the Pi Raspberry Pi. And afterwards we see here that if I choose yes, when I am prompted to basically accepting the connection to this part, the public key of the private public key pair generated will be added to the Raspberry Pi, and then I can easily use the SSH command to connect to the Raspberry Pi. And there is also a little modification which I want to do, which is that I don't want to always basically write this full path, but I also modify my SSH code to the etc ssh config, and here I create this host pi with user pi and the hostname Raspberry Pi identity file, and this way I don't have to always provide a full path, and I will be always authenticated using this key, and I then can just use the SSH pi, and I'm connecting remotely into my Raspberry Pi. Important part what I also want to do on the Raspberry Pi is that I want to go to the etc ssh. As before, we already know that the port 22 is open, but also I want to change the authentication method. So I want to make sure that I will be using the public key authentication method. So I have to set this to yes. And I want to turn off the tunneling using the original method, which is basically using the password connection, which is something not recommended, and it's not a good security practice. So I want to set the password authentication to no, and this way basically the configuration on the Raspberry Pi is finished, and I can securely connect over SSH to it, and also using the remote desktop connection. Now, when our Raspberry Pi is fully configured, we can summarize what we have learned. First, we learned how to select the Raspberry Pi for the development, where it is recommended to use the latest model with at least 4 GB of RAM. We installed the official Raspberry Pi operating system. Next, we set up the remote desktop connection using the remote desktop protocol, and finally, we set up an SSH connection to the Raspberry Pi from our host machine. With that, I would like to thank you for watching, and feel free to contact and raise any questions.